Okay, so we did not do C? Excellent. Somebody watching over your notes. What do we start with? Honest, who are we starting with?
Trevor.
Trevor? I was hoping you could tell me what we would call the inner function and outer function.
X to the 2/3 would be the outer function,
Perfect.
and the inner would be 5 minus 4x squared.
Excellent. Instead of writing x, how about, I believe on Friday I wrote it as a blank parentheses probably, right? Yeah. You guys can continue to do that if that makes sense. Otherwise, what you're gonna see a lot of times is they'll put a u in place of something, so u substitution. So I'll just write u to the 2/3. And then the inner 5 minus 4x squared, that was perfect. So my derivative is going to be, I don't know if I want to translate this for you or not, but the derivative of the outer times the derivative of the inner. So derivative of the outer is going to be u to the 2/3. Well, no, let me just rephrase that completely. 2/3 times u to the negative 1/3. So basically just did power rule. And then instead of me writing a u, I'll put the original information. And then times the derivative of the inner, 0, negative 8x. And then we simplify if we can. Bless you. Trevor, you in? Who's going? Oh, wait.
Wonderful. So, we want to distribute the power first.
Holy cow, how long's that cold lasting you?
It's not,
Forever, okay.
At this point, it's not cold. It's
Whatever.
small energies.
Oh,
But yeah, we want to distribute the power. So, power of negative 1/3. So it's
wait, what are you distributing it to, I guess is what I was
distributing
reading.
it to both the 5 and the negative 4
Okay.
squared.
Don't do that. If this was written as 5 times 4x squared, then you can distribute a power like you're thinking. So if everything is multiplication, then you can apply the power to all of them. If the symbol in the middle is a plus or a minus, so terms, then you can't apply a power. You have to, well, I mean, you have to cube root it, I guess. But you can't distribute it for pluses and minuses. Okay, can anything else go together?
We could distribute the 2/3.
It's actually the exact same reason you can't. With that power on there, we really can't do anything to the inside unless it's some sort of a perfect cube. So I can't actually multiply, is that what you're trying to say, the 2/3? I can't actually multiply that towards anything in there. The only thing I can combine it with is the negative 8x out there. So this would become negative 16/3 x, which, not great, not bad, whatever, times 5 minus 4x squared to the negative 3rd. This is free response, leave it there. Hi. Hi.
Here first.
There you go. Trying to remember what I was going to say.
You can't simplify.
Oh, right. I don't know, are we done?
We can simplify the 5 minus 4x squared by putting it in a fraction of that
to move it to the denominator, you can put it in your cubit, or you, so that one I'm always unclear on because they're the same thing. So moving it to the denominator is the only thing you're supposed to do to make it a positive power. It's kind of your choice whether you wanna make it a cube root or leave it as third power. I'll write this down, but I'll erase it. So this is not considered correct. I mean, what we did is correct and good and all, but this wouldn't be considered done, because you've got a fraction and a fraction. Does everybody know how to work that? Just trying to give somebody else a chance.
The 3 goes down to.
Okay, so there's two ways to think about it. One, you multiply top and bottom both by 3. And if you do that, that cancels the thirds. The other way you can think about it, since the negative 16 thirds is the only fraction on the top, this is the top, this is the bottom. And so the thirds just moves to the bottom. So there's different ways to think about it, but that's what we would simplify it to. Negative 16x over 3 cube root 5 minus 4x squared. This is what I am assuming is gonna be the worst part of these problems for you, is just to work on the simplifying. Because that's where I was seeing all the errors on the last test. We were gonna do that today, right? Let me double check that everybody's taken it. That was supposed to be right now, wasn't
I
it?
know.
Yeah, because what was your other, you said something else too. I don't think, I don't know if that's, oh, yeah, that works. I have eaten lunch, at least I've eaten. Sure, we'll do that. The last test is what threw me off. That's what most everybody did the worst on, was simplifying, was the actual algebra. So I'm assuming that might be similar for this section too, where it seems like for whatever reason you guys do really well on the new calc that you're being taught, but like things you're supposed to kind of already be good at, a lot of you just like forget the details. Not judging that blame, just that's what I kind of observed. Let's try the next one. Do you guys feel like you could try the next one on your own? Are you at that stage? I don't know what that means.
Identify which is the second.
Oh, okay, sure. So in my mind, when I look at this problem, I see e to a power. And it says e to the u. So to me, this is the outer function because it's the main focus of the entire thing. So this is going to be my main information to be the outer. So if you want to write it as a blank parentheses, go for it. If you want to write it as a u, go for it. The inner information in this case is 3x squared because that is taking place of the normal power. These are extremely simple, they just feel wrong to do. Like, feels like there should be more to it. All right, Demetrius, you got this. We do the derivative of the outer first. What's the derivative of e to power?
Is it just E still?
Yep, e to the same power. Yep, so you basically rewrite the exact same information. Times derivative of inner,
3x squared.
derivative of that though.
Oh, it's 6x.
Yep, perfect. To me, I would say there's no simplifying to be done. I don't know why, but for whatever reason, every time I've ever seen this on multiple choice, they always write the 6x first. I don't know if there's a particular reason for it, but that's how I always see it. I mean, I guess in my mind, like, I see zero difference. Maybe they partially do that so you're not confused what's the power and what's not the power, I don't know. Okay, good. How about we skip E? Because E is not terribly different than C or A. Or am I wrong on that? So E needs to be rewritten before you do the problem. Maybe I'll help you with that part. You need to rewrite it as -2 times 6x plus 3 to the -1/3. And that's what you would do derivative from. F is definitely what I wanted to focus on. F has multiple layers of chain rules. Let's start with the cubed. Does anybody remember what cosine cubed means? Oh, really? What's cosine squared mean?
You square the result of cosine.
Yeah, you take the final answer and then square it. They write it here so that you don't get it confused with the angle spot. So this problem, in our eyes, when we have a trig to a power, is the same thing as us writing cosine of e to the 5 theta cubed. Now I'm going to do this in colors because this problem will get annoying. Some of you are pretty good at doing this in your head. Some of you will need to be organized on paper. Okay, the outer function and the inner function. Outer is 100% the cube. The inner, does it make more sense if I write a U or just a blank parentheses? I don't know. Does the U confuse you because it's like a different letter? Because it doesn't matter to me. I want to write whatever's. Is it confusing either way? Okay. Inner cosine e to the 5 theta. Okay. Yep. Guide me.
So the derivative of the outside.
Yep.
So
Were you staring at the blue formula?
yeah.
That's impressive if you're using that as a guide.
Okay. Take you plug in the cosine e5, cosine e to the 5 theta into the u.
Okay.
In the parentheses and take the derivative.
Okay. What's the derivative? That's what I was waiting for. But you are correct. The original information will still be written in there. So what's the derivative of cube?
2 theta squared.
Sort of. Power rule.
Yeah. make the coefficient to.
Power? I make the power to, what do I do? Three.
Make that the.
Okay, so 3 in the front. I'm going to write the exact same inside, but now with a square. So at this stage, I don't care what the inside is, I'm just gonna rewrite it. No matter how complicated it is, I just rewrite the inside. Okay, now we've got derivative of cosine e to the 5 theta. Oh dear. So cosine e to the 5 theta absolutely has an inner and an outer piece of information. So I am going to take this and I am going to start my own chain rule to find this derivative. Because right here, I'm supposed to write the derivative of the inner. Well, my inner has a bunch of information, so it's not like simple, straightforward. So I'm going to start inner and, I don't know where to write this. That won't hurt right there. Is the right above it? So the main focus, the outer, is the cosine. So cosine of an angle is my main function. The inner part is e to the 5 theta. Okay, well, the derivative of this blue information that I wrote down is going to be derivative of the outer, which would be negative sine, same angle, e5 theta. So it's basically like I am starting a separate problem and writing that answer in place of my derivative of the inner. So derivative of the outer is this, times the derivative of the inner, and I still have another set of inner and outer information. So derivative of my inner is a new problem. Now, I'm not expecting you guys to just be always writing this out. I'm trying to explain how I go through it in my head. Basically, each time I ran into something different, I have to take like a separate derivative. Okay, so e to the 5 theta, the outer is e to the power. The inner is 5 theta. Okay. Well, the derivative of this is going to be the derivative of the outer, which is e to the original power, times the derivative of the inner. And in this case, I'm finally down to simple, straightforward enough that it's just one of these derivatives. If you can break it down far enough so that it's just a straight derivative, then you no longer need to do the chain rule.
Which one is the
5 theta. Now, we're 100% not done, but I'm just showing you where the parts of the answer came from. This one is easily one of the most complex ones you'll run into. Very seldom do you get one with 3 layers. Trig just happens to do that because of the way the angles work. Okay, but I have to simplify it to actually have a final answer. Well, I've got a 3 and a 5 and a negative 1. So I've got a negative 15. And then, honestly, there's no particular better order. It doesn't really matter from here on out because everything's so different. I guess I'll just put the E one next. and then the trig was. So I wouldn't put cosine with a squared like that. I would write it as cosine squared e to the 5 theta times sine e to the 5 theta. I'm not trying to scare you. I absolutely wanted to do this one with you because I need to show you how to go through the process. Again, practicing hard problems is better than being given a hard problem later on and never tried it. I'm positive you have questions, maybe you don't even know what to ask questions from. Do you want me to go through how I would do this without writing that down? Okay, so I basically wrote down my mental process. Okay, so I would have seen this and I would have known cubed is the main deal. So I would start off by doing 3 times whatever that was squared. I don't even care about the inside information when I'm doing that. So that's why in my head I usually do 3 times something squared. Well, then I know I need to take the derivative of that. Okay, I ignore everything else and I focus only on cosine e5 theta. I know the derivative of cosine of anything is negative sine of same thing. Like the angle will never change. So derivative of cosine is negative sine, same angle. I have to take the derivative of the angle. So I'm kind of just working my way in. So the derivative of e to the 5 theta would be e to the 5 theta times derivative of 5. I kind of work my way from the outside in and keep taking derivatives if I need to. Basically, if something isn't a plane x, if something isn't a plane x, I keep taking the derivative towards it. And to be honest, it's harder for me to actually write it out than it is to just do it. From a level of 0 to 5, how are we feeling about doing one of these on your own? Honestly, 3 is totally good. Hopefully you guys aren't feeling like 3 means you're struggling. That's normal. Okay, I was gonna say, I felt like this page had some other stuff. Let's do H. Let's just go right into the meat right in there. H is horrible. Let's do it. Should I give you some guidance? Yes, okay. Elena? What? You get to leave? I should have just stolen your pants and left myself. Any thoughts on how to start this one? What's the first thing that sticks out to you on this problem, I guess? I don't know. Okay, we've got, that's in the power. The power is the very first thing you said. Was that sticking out to you because you don't like elevators?
Yeah.
Okay, that's fair. I phrased it badly. What's the main layout of this problem? Yes. What does x squared e mean?
Is that the inside?
No. Onyx, what were you gonna try to answer? You raised your hand, I think, right?
So x squared e is the outer, right?
Nope.
Because, no?
Wait, theoretically, that's not wrong. You definitely don't want to view it that way.
Is it, outer is x squared and then the power and e is the inside?
You guys aren't wrong. To me, the main part of this problem is the fact that they're being multiplied times 2 functions. There's 2 different functions here. And so since they're multiplied, we have to do product rule. That was bad enough to call for a bro. Oh. So when I'm looking at this problem, I want 100% focus on the fact that I have two separate problems written next to each other, which means they're multiplied. So this is my F, this is my G. Off on the side, you probably want to set up F, F prime, G, G prime. G prime is where you're going to need the inner and outer information. F prime is just X's, so that one is straightforward. See if you can figure out H. Find the derivative. I'll do it with you at the end here. I haven't done it, I have no idea what the answer is. The weird part is the next question has this giant space to do the problem, and the next question doesn't need it. Okay, that's the correct product rule. What I want you guys to focus on is how to simplify it. There's where I got the parts from, if you need it. So the derivative of e to any power is to have e to any power rewritten. So I always rewrite the exact info. And then I need to take the derivative of the power. So the derivative of negative 4 ln of x. The negative 4 is a number multiplier. So that'll just follow with it. And then the derivative of ln of x is 1 over x. So negative 4 times 1 over x was my derivative of the power. Izzy, you got this? Are you feeling confident on the simplifying? Was that a no? Should I have you guys, to me this is pretty important because this is the part you guys are having trouble with. Should I have you guys like work with each other for like 5 minutes to see if you can simplify that? And then see if you can come up with a good final answer? Basically, factor things out if you can. move negative powers if it has any, combine like terms if it has any. You just do anything you can. That's pretty much what simplifying is. Work with each other. I don't care who you with. I mean, like, if you want me to like pair you guys up or something, sure, but like that's generally the easiest way to do calc is with other people, because then you hear things that you might have forgotten about. And I can tell you the correct answers all day, but that doesn't always help.
The calc itself is quite, like the formula because what I did was I simplified the -4 over x to -4x minus 1.
Calc is mostly a lot of mental organization. If anybody's feeling confident on their answer, they can certainly put it up there. Ooh, we've got a brave soul. I feel like I should have some sort of prizes or presents for people who are feeling brave. Huh?
So,
Oh, those are gone, long time ago. Ooh. You don't have to stay within the box. So the only thing you did there was just multiply x squared and -4 over x?
Yeah.
Okay,
and then
so close. So close. I will say, you pull, that's the correct information that should be factored out. I think that's what you were trying to do.
yeah.
But if you factor something out, you can't just like pretend what you factored it out is.
Oh wait, no, I just added them together. 'Cause they have the same exponents.
I didn't even notice that. Oh, yeah, you're good. Oh, I was gonna factor it out, but you're right. The information that's left is identical anyway. Oh, nice job. That was much easier than what I was gonna do. I was gonna factor out the 2x from both of them, and then the e to the -4 ln x, and then the inside of the parentheses would be left with -2 plus 1. And that would have, I mean, not that that would have been hard, but that would have been a lot more steps than what you did. You guys need explanations? Okay? Can you read what he wrote fine? Which, oh, no.
I don't get why there's no.
Are you being sarcastic or serious?
No, I'm being genuine.
Okay, that's fine. I'll rewrite. I think you wrote that too, right? Okay. So, first thing, and for the most part, the order you do this isn't like you usually do. You multiply those two together. the x on the bottom will cancel with the squared on the x squared. So then you would have negative 4 times x. E to the negative 4 ln x. Second term, nothing goes together, but for the most part, most people write it in the front, like a multiplier in the front. But it technically doesn't matter. I wonder if I should explain my method, because it's so awfully rare that you'll actually get like terms. Like, it's actually kind of crazy that these actually had like terms. Do you want, can you guys picture the like terms that I'm talking about? Should I emphasize or show that? They both have this exact same letter equation combination. And so you can think of that whole thing as the term. So since they have identical information, you add the numbers in the front. So negative 4 plus 2 is negative 2. And that's the number that you would write on that term. So that method 100% works. What I was gonna do, which isn't like better, and honestly just made it longer, I noticed that they both had the exact same info there, and so I factored it out. And if I factor that information out, I'm left with just negative 4 and just 2, which I then add those together and multiply it on here, and it gets the exact same answer, but in more steps. So this would be the simplified answer.
Should you bring the E of negative 4 ln of x on the, as a bottom denominator to make it positive?
That's a good question. I'm completely unsure how they would write that. I don't know why, but a lot of times they treat this not as a negative power, because you don't know what's going in place of x. But if you did, 100% that could be correct. Like, there's nothing wrong with you doing that. I don't know which one will be on multiple choice. What time did we get done? 27? Okay. Should we do one more? Ooh, and I was gonna do I with you guys, but I like K better because that's on the AP test every year. Is it that bad? On here, the sides are getting so loud. Joe, lead us.
Use the product rule.
On what? K?
I was doing J.
J. You would be correct on J. That would be product rule.
Are we doing K though?
I wanted to do, yeah, I guess I didn't really emphasize it. This is on the AP test every year, this same question, they have it on multiple choice. So, might as well just do it because you guys are going to get this one.
Would you pull out, like, oh,
You're not Joe.
what?
She can answer that.
Oh, you want her to answer it? I see,
No, I
okay.
was saying go for it.
Go for it.
The outer function is that first ln of x, and then
Is it helpful when I write outer and inner? Okay, go ahead. What you said was fine.
is the ln, and then the inner is gonna be the ln of x.
Yep.
And then you, like, the ln is gonna become 1 over ln of x.
1 over the parentheses spot,
Yeah.
yep.
And then, the inner is gonna become 1 over x. And just multiply that out.
Perfect. It seems like a really stupid one because ln of x like, doesn't make any sense, and 100% does not. Like, I doubt that ever stands for anything ever. But the AP test, they like to test you on just the fact that you know rules and properties of things, and so you can do whatever's given to you. This one would definitely have like domain restrictions, because you can't put in a negative number in place of x. And in fact, what's even weirder, you can't have a negative number inside of a natural log. Like if I graph natural log, it graphs like that. 1, 0. Wait, is that 1, 0 or E 0? Ln of 1 is, yeah, 0. So this can't be negative, and the x can't be negative. So the domain restriction is you wouldn't be able to use any x values unless they were bigger than 1. Because any number you use that's smaller than 1 would make a negative natural log, which wouldn't work. So we haven't needed to worry about any things like that yet, but as we go throughout the year, they start adding in details like that. Okay, good. I don't know, did you guys get that one okay?
So why is it x ln x instead of ln x squared?
You can't multiply the natural log information with outer information.
Okay.
If you kind of remember the natural log properties, if I really wanted to, I could bring this inside as a power. And so I could write it as 1 over ln of x to the x.
Okay.
But that doesn't really click with most brains, so this is considered better. But basically, you can't multiply inside and outside of natural logs. Okay, let's do m. Let's just go right for the ones that everybody usually hates. I mean, it's no good to do the ones that seem easy to you. Might as well do the horrible ones. Should I say try to do this all in your head? Maybe not. First thing, the square. Make sure you write it as a it's like a squared up. Try to find the derivative all on your own. I'll put the answer up here so you can check it when you're done. if you are writing down inner and outer, like repeatedly, just remember that when you get to the derivative of the inner, it's almost like starting a new problem over again until you get all the way to pi theta. And then the derivative of pi theta is just pi, so that one doesn't need its own chain rule. So this one has 3 chains. No, 2. Yeah, 2 chains.